Okay, let's go ahead and upload the code. Okay, so as you'll see, the game first plays 4 notes randomly, and it's expecting you to replay those notes in order for you to win the game. Remember, this particular pin, or this particular button I should say, corresponds to this buzzer. This one corresponds to the second one, and this third button corresponds to the third buzzer here. So right now I actually forgot what sequence, so I'm just gonna get this wrong, right? So I'm gonna try to play this back, and you'll notice that it tells me that it's wrong. So then it plays back the sequence that I'm supposed to play. So I think I remember it now. I'll go ahead and try it. Oh, got it wrong. Okay, let me listen. All right, so it's all right. So if I won, the first light is gonna light up, and then it plays again. So it's another random sequence. Got it right. And let's go one more time. Okay, I got that one right. Now what I'll also show you is that you can increase the difficulty level of the game. If you look at our code, and we were to change the note sequence, so here we're playing with 4 notes, I can increase this, let's go up to 6. So by changing the value of this array, I'm able to make the game even more difficult. So instead of 4 notes, now I have to remember 6 notes. So when it gets uploaded, they're gonna play now, 6 notes. All right. One more. There we go. All right, so you get the idea. This is crazy addictive and lots of fun, so I encourage you to play around with it, change the difficulty level, and you can play this with your friends and your family. So for this project, we will be using a third-party library, Bounce2, which helps us with the bouncing to figure out exactly when our switch is pressed. So let's first download that third-party library, and we will install it in the Arduino IDE, and you'll see then we can be able to use the library as part of our project in our code. So I'm going to put the link to the library actually in the resources for the project, but if you just Google the Bounce tool library for Arduino, there is a GitHub link that you'll come across. Thomas Fredericks wrote this really handy library for us. Let's go ahead and download that. So you can download the zip file. I'm just gonna put that on my desktop here. So I'm gonna save that. When it's finished, I will unzip it. Right, so now that it's unzipped, here are the files for Bounce, the Bounce library. Remember, for third-party libraries, we have to rename it. So I'm gonna take off this master at the end, the dash master, and just leave Bounce2. And now I'm going to copy this into my Arduino folder where the other libraries are stored. So if you remember, if you recall, if you go to your Arduino and you look at your file preferences on Windows, Arduino preferences on the Mac, it should show you where the location, your sketchbook location is. This is where in here there would be a libraries folder, and this is where you'd want to copy any of your third-party libraries. Okay, so let me go back and copy that library over. So I'm going to copy that bounce to library, and I am going to go here in my particular installation. It's in my Arduino libraries folder. Here I'm going to paste that bounce library, and now I already have that installed, but here's where you would just include any libraries that you'll use. After you do that, you'll want to restart your Arduino. So go ahead and close it off, restart your Arduino IDE, and then you'll be able to use the library. So let's take a look now at the code for our project. First, we include that new bounce library that we installed, that third-party library, so we can use it. And at the top, we define our buzzer pins. So buzzer 1 is pin 8, 9, and buzzer 2 is pin 9, and buzzer 3 is pin 10. And then we define our buttons, right, on pins 5, 6, and 7. Next, as part of the bounce library, we want to instantiate bounce objects. So we created the bouncer 1 object, and we instantiate that by calling the bounce constructor from the bounce library that we imported, or we included. So we have the bouncer 1, the bouncer 2, and the bouncer 3. Those are bounce objects. Next, we have a note sequence, and this is will determine the number of notes that we recall or we have to play back. So you can play with this number to make the game more difficult. I think by default it should be set to 4, but you can increase this or change it as you will. The number of notes, we determine that by doing a size of note sequence. That will give us the size of the memory allocated to note sequence, and we divide that by the size of one integer, and hence we get the number of notes. So that allows you to tweak this, and just by tweaking this one variable, the number of notes to play back will be calculated. The current note, this is a global variable, we set that to 0, and the challenge played, it's a global Boolean variable, we set that to false. We'll see how we use those a little later on. Setup, very straightforward. Here we do our pin mode, button 1. We use the input pull-up resistors, that way we didn't have to connect any resistors to our push button switches. So we do that for all 3. And here, as part of the bouncer library, we want to attach button 1 to the bouncer 1 object. So that's how we're able to associate the particular buttons with the bouncer objects. Okay. Then we generate a random play sequence. So that's the function that's going to generate a random number for us. This particular line of code, random seed analog 0, Arduino has a sort of a hiccup in that if you were to generate a random number, it remembers that. So every time you reload you apply power to the circuit, it would generate the same initial random number. So to make that totally random for the very first time coming in, we can use this random seed function, and we do an arbitrary analog read on pin 0, which again, that's a random number that will be generated, and that would give us a true random number the very first time in. Let's take out the generate random play sequence function. So I'm going to go down here a bit. So here we loop over from I starting at 0 till the number of notes. We get a random number between 1 and 4, and we we store that in the note sequence, a note sequence array. So basically here we're building up the number of notes. So we're setting up what that play sequence is going to be, and we're storing it in this note sequence array. So let's check out our loop function. So in our loop, we check to see if the challenge was played already. If it was not played as yet, we set challenge play to true. The current state is 0, and then we play the sequence. So there's a handy play sequence function which takes in the note sequence which we generated. And I'll go down to that play sequence. And So here's the play sequence. So it loops over that notes array that was passed in, and it plays each note. So that's how you hear the tones being played. So for play note, that function is fairly straightforward. It just takes a note and it comes in here, and if the note was 1, that means it would be playing the first buzzer. So you do a tone for buzzer 1, we set the frequency at 2000 Hertz and there's a delay, then we turn the buzzer off and then there's a short delay. If the note is 2, we play the second buzzer, and then 3, the third buzzer, right? So this just plays the corresponding buzzer. Also note that we set the frequencies at different levels, so that's where how you can hear a different pitch sound for each buzzer. So that's basically the play note function. Alright, so now we get back into our loop function here. In order to keep track of the bouncer objects, we have to call the update function. This is just the standard documentation with that bounce library. Next, we do a read. So now here's where we want to determine which switch was pressed. So basically, we store that and we check to see if the bouncer 1.fell, that means the first switch was pressed, we would play note 1, right? So that's when the user is involved or doing the playback. So we play note 1, and then we will verify note played is correct. We pass in 1. So if the user pressed 1, we want to make sure, oh, is that correct? And I'll just quickly go to that verify if note is played. We come into that note sequence that we initially set up, and we check to see, is the current note, the order at which you play back, is that equal, the note that you played, to the note that was stored? And it continues on, and you iterate over this function, and when you reach the end of the sequence, if the note that you have played is equal to the number of notes, you're done. Meaning you're at the end of the 4th cycle or the 6th cycle, or however many notes that you had set up, and then you would be a winner. So we call the winner function. Else, if you were wrong anywhere in the sequence, we call the loser function. So just quickly looking at the winner and loser functions. For winner, we get that beep, beep, beep. So basically, here we want to make sure that for 3 times, we set that tone on that buzzer 3, so we hear that quick beep, beep, beep. And we do that, and then we exit out. So that's the winner. For the loser, as you mentioned, you get that beep, that one long beep. So here is where we use the tone function to sound that buzzer once. We do a 1-second delay, turn it off for 2 seconds, and then we start the process again. So quite a lot of functions in here. It's very modular and broken up. I'd encourage you to take a look at the code and go through the different functions. But barring the bouncer library that we pulled in, that really helps us. It's, as you can see, to determine if a switch was pressed. It's very straightforward to do that. We just check to see if the bouncer that fell, that tells us that if the switch was pressed, we don't have to deal with any timing issues or any false positives. We know that that switch was pressed. We can verify if the note is correct, and so forth. So that's our game, and that's the code review. To summarize, in this project, you learn how to incorporate a lot of basic components in an Arduino project. We were also able to introduce a third-party library to help out our project. These are useful and help us to really focus on the unique problems we're trying to solve. Arduino is open source, and many open source libraries from those who have already solved common problems in the community exist that you can leverage, just like our debouncing library. If you build libraries as well, contribute back out to open source and contribute to the movement too. This was a great project, and by successfully completing it, you would have mastered quite a lot of skills. Let's keep the momentum going.